A core feature of running Linux is that you have centralized software management. Instead of having to track down new EXEs and install updates individually through every interface, you can actually go through and do every package on the system all at once. Each of these are controlled through a list of repositories, which we'll show right here. The repositories control package sources, and from those package sources you can pull in different package updates. And all of those go through a centralized package management called apt, which is based off the original Debian version. To get a feel for how it works, let's go ahead and install the Apache 2 package. Apache 2, or just Apache, is a web server that's pretty much the de facto standard for Linux installations. The first thing we want to do is use apt cache to search for the package. We don't really know necessarily what the package name is called, but we know that we want something like Apache 2. And then you get a huge list of things. You see there I'm pointing to PHP5-CGI, which is a CGI version of PHP. If we take a look at it for a little bit more in-depth information using apt cache show, it shows you there that PHP5 is an HTML embedded scripting language. If we had wanted to install an HTML embedded scripted language, then this would be a good place to start. Once distributions had developed this method of shipping packages for software instead of individual installers, it allowed them to move into whole system package management, which means that from one command line, or at least one set of utilities, you could update and install software from many channels and always stay current with it. In order to do that, they created a series of applications like apt-get or apt-cache so that you could search the current package cache. And then, building on top of that, instead of installing individual packages, you can move on to installing entire systems. So if you install Apache 2, the package name, then it would actually cascade and install the entire series of packages that Apache 2 needed in order to run correctly on your system. Previously, before package managers were really prevalent, you would have to download and install the source for Apache, or download it, and then attempt to compile it, find out everything that was missing, download everything that Apache needed to compile those first, and it was this vicious cycle of never having the correct software. Package management fixes that, and so it's really important to understand how it works. Between the time when the CD is created and when you do the actual installation, a lot of packages will be updated. So we do an apt-get update, which pulls in all of the repository information that we talked about earlier, and then updates the available package list on our local system. That way, when you go to do something like an apt-get upgrade, it's working on the most frequent, or the most recent version of packages. An apt-get upgrade, in this case, is going to upgrade every package on the system that has any type of update available. It's a good idea to go ahead and do this on any type of server that you're building new, but isn't in production yet. That way you know you have the most recent packages. I'll speed this up real quick, because it ends up being a lot of stuff to download. But what you can see is that there's a list of packages, and then it resolves the dependencies based on what your normal upgrade path would be. So every package on the system that needs an upgrade is going to get one now. And it takes a long time to download, so I'm going to accelerate it even farther. These package files are essentially just tarred and compressed. We'll cover that later. But they're effectively zip files that have some metadata attached to them. Perhaps an XML file that explains what other dependencies there are on the system. So it could be that you're installing the Linux image 2.6.35, and it has a ton of dependencies like a C compiler or a set of libraries. If you don't already have those installed, the apt manager will go ahead and install them. And additionally, if you have older versions that also need upgrading, it will resolve those dependencies for you as well. Now that we have an up-to-date system, we can go ahead and start looking for individual packages to install. In this case, there's basically one command we want to use, the dpkg, or a lot of people will say dpackage. It works on an individual package instead of apt-get, which works on an entire system of dependencies. So a dpackage-l will list all of the packages currently installed on the system. We can pipe it to grep in order to pull out one individual package that we're interested in, or we can just page up and down to look at the list in total. One thing we see here is that there is a version of traceroute installed, which looks kind of interesting. It's just a quick example that I picked. We're not going to do anything specific with it, and also that SSH is installed. You'll note that the first column, II, basically just means it's installed. There's other positions that it could be in, like an R, which means removed. There's a really useful text mode web browser called W3M. On any system that you run, you're probably going to want it. But for now, I'm going to remove it as an example. When you remove it, it actually deletes the binary files and some of the configuration data, the help files and things like that. But it isn't going to remove anything that's user-specific configuration in general. Also, remember that you have to manage packages with root, because sometimes I forget myself. It's not so much that I forget you have to be root, it's that I normally do things as root, and so I don't always use sudo. That's a bad practice, and you should probably always use sudo. Sometimes bad examples are important also. Since it's now uninstalled, we can go ahead and reinstall it using just a standard apt-get install. You'll see that I forgot to do it as root again. Remember, bad examples are also useful. Once it's installed, and it's downloading a newer version, we'll be able to use it as a text mode web browser. But it's really just an example on how you do single package management. The bad thing about single package management is that it leaves artifacts lying around on your file system. So apt-get has a remove function. Not only will it remove the package that you're specifically asking it to remove, it will also remove any packages that are solely dependencies. So that is to say that without W3M, the W3M img package is no longer required on the system. So apt-get goes ahead and removes both. There's also an option called apt-get auto-remove, which goes through your system and finds all packages that aren't required anywhere and removes them. It's a good way to clean up space, but it can be kind of dangerous. Auto-remove normally does the right thing, but it's perfectly conceivable that one day it might not, and it will remove some sort of dependency that the apt package manager has confused or been corrupted, and then it will remove files that you care about. The last thing to keep in mind here is apt-get clean. You store all of the downloaded binary packages on disk, and they take up space. Make sure to clean them.